David, the floor is yours.
Okay, so good day. My name is David Villiers, and I'm presenting a paper on the asymmetric effects of heterogeneous capital flows on the credit cycle. My focus is on the overarching role of the International Monetary and Financial System, or IMFS, which amplifies excess financial elasticity of domestic policy regimes. So, Villiers and Descriptive had found that the IMFS is characterized by excess financial elasticity. This amplifies inherent systemic risk. In short, what we mean by this is that the amplitude of the financial cycle is orders of magnitude larger than the business cycle. We highlight this in the figure on the right-hand side. What's important is that gross flows exceed net flows. The quantity of foreign exchange traded exceeds the quantity of trading goods and services, leading to financial imbalances. This disconnect is the excess financial elasticity and ultimately leads to instability. This paper contributes by identifying the mechanism or channel of the excess financial elasticity. How do you bring this back to the credit cycle? Well, the credit cycle is the expansion and contraction of access to credit over time, and developments in the credit market lead to financial vulnerability. This paper presents evidence of how heterogeneous international capital flow episodes drive the domestic credit cycle and financial instability. We model the credit cycle and investigate the empirical link between the probability of domestic credit booms as well as busts and heterogeneous capital flow episodes. Heterogeneous capital flow episodes are delineated by their origin and direction. Forbes and Warnock characterize capital flow episodes as surges, stops, flight, and retrenchment. With respect to foreigners, surges and stops represent sharp increases and decreases in gross capital inflows. And for domestic investors, flight and retrenchment represent sharp increases and decreases in gross capital outflows. Previous literature often neglects this difference. Finally, given that international capital mobility creates domestic financial instability, we evaluate the historical role of capital flow management measures such as macroprudential policy and capital controls as policy tools. The figure borrowed from late 2018 plots capital inflows disaggregated by asset types, so FDI, portfolio equity, portfolio debt, and credit, as the proportion of world GDP for the period from quarter 1, 1990 to quarter 4, 2012. It also reports the VIX on an inverted scale on the same graph. The VIX is a measure of uncertainty and market risk aversion. It is interesting to note that when the VIX was lower between 2002 and 2007, capital flows increased. This highlights how capital flows are negatively correlated with global risk factors. This is also a preliminary indication of excess financial elasticity. To quote Ray, credit flows are the most volatile and pro-cyclical component of all flows, and the credit flows in particular had a dramatic surge in the run-up to the great financial crisis and an equally dramatic collapse during the crisis. So what I want to highlight is that the credit, or the red line, which refers to bank credit, is the most sensitive to the VIX, followed by debt and then equity, which are portfolio flows. We see that FDI, the blue line, is more robust and that is less volatile in response to uncertainty in the stock market. It is essentially a risk aversion proxy. But financial integration can lead to large and persistent global imbalances when countries differ in the degree of financial development. To put it differently, financial openness without financial integration creates a space for systemic risk to flourish. Let's delve into this difference. Financial openness is a measure of your exposure to external shocks, basically gross flows. Financially integrated is similar, but it goes further. It means that you have a developed financial market. This allows for avoiding contagion. The degree of financial openness is different from integration. Simple measures like gross foreign assets and liabilities can proxy both, but the degree of integration can be thought of as access to foreign funding, liquidity, and functioning of financial markets. Moreover, financial openness generally refers to the degree of controls and or restrictions on current and financial account transactions. Therefore, financial integration breeds systemic risk because financial integration is how closely an economy follows the financial cycles of the IMFS. Global imbalances lead countries to gradually substitute savings for foreign liabilities, and this also affects the composition of the portfolio of net foreign assets. In countries with deep financial markets, this manifests itself in the form of increased credit. However, credit booms are also linked to larger pullback by international investors during a crisis. So we can say that the IMFS incentivizes, exacerbates, and creates flows that cause a buildup of imbalances. The unwinding of these positions leads to macro fragility. Credit thus exposes countries to risk of instability because it ultimately presents itself as credit booms and busts. An example is expanding credit that comes in the form of asset prices that lose touch with their fundamentals. We can therefore say that this disconnect is cause global imbalances and leads to a pattern of capital flows that generates excess financial elasticity. Economies become more financially integrated, their economies become more synchronized with the IMFS. For instance, in the literature, it was shown that correlations in GDP fluctuations across countries rise with financial integration. Theoretically, this is due to international risk sharing. To tame this elasticity, capital flow management measures are important. These policies tie the response of flows to the institutional structure. This brings us to our first primary research question. What is the impact of the exchange rate and heterogeneous capital flows on financial stability? So what we want to do is focus on detecting the mechanism of excess financial elasticity that was identified by Villiers. The literature indicates that surges in capital inflows typically lead to asset price bubbles and credit booms. We are interested in what about heterogeneous capital flows impacts financial stability as measured by credit cycles. Popular methodologies to do this are binomial regressions. An example from the literature is Avjeev et al., who use a Probit model. They focus on various depth dimensions to explain the boom-bust phases of the credit cycle. Ours is different in that we focus on heterogeneous capital flow episodes. Nevertheless, the Probit specification models the probability of being in one of the states, either boom or not boom, and bust or not bust. We stick to the Probit specification for both booms and busts so we can better compare how factors impact the likelihoods of booms and busts. The gulf between the distributions of booms and busts, as you'll see later on, might actually imply the scope to use different estimation procedures. What further differentiates our study from previous ones is where Forbes and Warnock focus on identifying the currents and drivers of extreme capital flow movements, building the dataset and distinguishing between incidences of flight, retrenchment, surges, and stops. We use these variables in our dataset to explain the credit cycle. The figure on the right-hand side documents the heterogeneous capital flow episodes between 1985 and 2020. And we see that during times of crisis, such as the 2007-2008 financial crisis, there's increased capital flow activity. The spikes are clear. The figure also shows that capital flow episodes are not evenly distributed across time and are bunched together in waves. So our quarterly dataset spans 1986 quarter 1 to 2020 quarter 3 and comprises of 32 countries. The BIS dataset on total credit to the private non-financial sector is used in order to identify the different phases of the credit cycle, and we'll circle back to how we identify credit booms and busts in later slides. For the heterogeneous capital flow episodes, we make use of the Forbes dataset, and in line with the literature, other control variables are listed here in the slide. The descriptive stats and correlation heat map is on the next slide, and we'll talk about capital flow management data when we get to the second research question. Here we provide the descriptive stats and correlation heat map. So what I want to highlight here is that in the mean of the descriptive stats, booms happen about 5 times as often as busts. The credit cycle is therefore not symmetrical and is comprised of more booms than busts. In terms of the correlation heat maps, booms and busts are negatively correlated, but this has to do with how we define these variables later. And we can see that flight are moderately correlated with surges, and retrenchment is moderately correlated with stops. And this is an indication of a feedback mechanism between foreign and domestic capital flows. So we identify episodes of credit booms and credit busts using the methodology outlining Agnella 2015, Burnside 2016, and Avjeev 2021. So we propose the following Probit specification in order to investigate the impact of heterogeneous capital flow episodes on the credit cycle. With the probability of a cycle phase given capital flow episode C and control variables X is equal to some function psi of these variables. Where the cycle phase is either boom or bust, alpha and beta are the vectors and parameters to be estimated, and psi is the cumulative distribution function. We assume that the cycle phase is distributed according to the standard normal distribution, and since we rely on panel data, the structural models are as follows as seen on the screen. Where the cycle phase IT is the latent variable, I denotes the country, T corresponds to quarter, and I want to point out that we will have two separate equations, one for booms and one for busts. So where do we get these booms and bust series? What we want to do is detect upturns and downturns in the real credit cycle, upturns and downturns in real credit to the non-financial sector. So in the figure, we want to go from the jagged black line to a series of ones and zeros. So for easier explanation, I will explain only in terms of booms, and I'll minimize the quantity of math in the discussion. So step one, we calculate the log of real credit growth in domestic currency. Then we calculate a centered moving average. What this does is it smooths the series, and this helps move quarterly variation. So now we work with a smooth series. Next step is that we difference the series, and we define our upturns to correspond to periods where this difference series is positive for all time, and a peak is the last time period in which our series is positive. We do this for all the cross sections in the panels, and then we calculate each cumulative upturn. Next, we find the average cumulative upturn for the entire sample and classify an upturn as a boom, i.e. 1, if the upturn is greater than this average, else the upturn is coded as a 0. Quite analogously, we create our bust series. The main difference is the switch to the focus on when the difference series is negative. Using this methodology, we can confirm the cycle is asymmetric. So in the figure on the right-hand side, we see the case for South Africa. The blue regions indicates a credit boom and the red a credit bust. The circled region indicates an upturn which did not meet the threshold to be classified as a boom. If we look at the full sample, booms correspond to periods of cumulative upturns of 35%, and busts are cumulative downturn of -4%. And if you compare our thresholds to other studies, I've found thresholds of 51% and -7%, but we do have a longer panel with fewer cross sections than them. And using other methodology, Arena 2011 found a threshold of 30%. And whereas specifically for the UK, Eichmann et al. Found credit booms to correspond to cumulative growth of about 24%. So in our study, if we isolate the UK, we have a boom threshold of about 26%. So we can therefore say that our credit cycle corresponds to those found in the literature. So what are the main results? We focus here on just the Probit models, but I can report that the Probit results are consistent with the baseline LPM. For the Probit, there are some challenges associated with interpreting these coefficients, so we'll look at the average marginal effects in a later slide. I just want to focus on some significant findings here, though. So with regards to the extreme capital flow episodes, controlling for other factors, we find statistically significant evidence of asymmetric effects on the credit cycle. We highlight here that surges are significant in both the boom and bust equations. When we omit our control variables, the signs are the same for 7 out of the 8 variables. The general notion is that heterogeneous capital flow episodes positively affect the likelihood of a boom, whilst negatively impacting the likelihood of a bust. Another general observation is that the exchange dampens booms and amplifies busts. So if you look at the average marginal effects in the table, it presents us values that can be intuitively interpreted in terms of how the variables affect the probability of a credit boom or bust. For instance, based on the sample, the parameter value of 0.046 implies that an increase in the year-on-year GDP growth by 1% increases the probability of a credit boom by 4.6% and decreases the probability of a credit bust by 2%, ceteris paribus. Similarly, an extreme capital surge increases the likelihood of a capital boom by 19% than if that surge did not happen. In terms of model diagnostics, we plot the receiver operating characteristics, the ROC, for the credit boom and credit bust equations. The ROC illustrates the diagnostic ability of our classifier system. The technique and name was derived by military radar receivers during World War II. The ROC plots the fraction of y equals 1 observations that are correctly predicted, aka the true positive rate, versus the fraction y equals 0 observations that are correctly predicted, aka the false positive rate. In the figure, we've plotted for both the credit boom and bust equations. The dotted line represents the random classifier, 50-50 chance of correctly predicting the outcome. So the ROC is above this line. We know that the model is better than the random classifier. We can also estimate the area under the curve, or AUC. An area of 100% represents perfect classifier, and 0% the model gets it wrong every time. So the AUC for the credit boom model is 75.7% and 73.6% for the bust model. So this brings us to the second research question. What is the historical role of capital controls and macroprudential policy? In order to broadly evaluate
5 minutes.
CFM measures, we make use of the Pashrisha dataset on capital controls. We look at the tightening and easing measures. The series captures the number of inflow and outflow tightening and easing measures employed. We also use the Suruti dataset, specifically the cumulative aggregate index that incorporates various macroprudential policies. The aggregate index is used over its components in order to bypass selection bias. So as we know, macroprudential policy tends to be very country specific. And because countries that are prone to financial instability are fundamentally different to those that are not, Probit methodology is not the best specification to overcome this selection bias. So hence I'll focus on the aggregate index. So the capital control data shortens our panel to Q1 2001 to Q4 2015. The new baseline is omitted from the slides, but it is in line with the previous findings. We see with these capital controls is that the inflow measures positively affect the probability of boom, with only easing being significant, whereas outflow measures negatively impact the probability of a boom. And in the credit bust equation, we see the inflow easing and tightening, as well as outflow easing, all decrease the probability of a boom, and outflow tightening increases the probability of a credit bust. And we get to the Saluti macroprudential data. The shorts are original panel to 2000 Q1 to 2018 Q4. Again, we omit the new baseline from the slides. When we see here where capital controls had mixed effects on the probabilities of booms bust, aggregate macroprudential measures decreases the probability of both booms and busts. So macroprudential policy therefore smooths the credit cycle. So if you look at the marginal effects of all the capital flow management measures, we see that historically capital controls and macroprudential policy tie the response of flows to the institutional structure, and the easing of capital controls is found to decrease the probability of credit busts. Outflow measures decrease the probability of booms, whereas inflow measures increase the probability of booms. And in contrast, macroprudential policy unequivocally smooths the credit cycle. So it brings us to our conclusions. The main finding is that heterogeneous capital flows have asymmetric effects on the credit cycle, and capital flow episodes amplify credit booms and dampen credit busts. In terms of policy, to avoid a credit bust, the obvious solution is to avoid an unsustainable credit boom in the first place. The risk of stopping a boom must be compared against the possibility of a credit bust and financial crisis. The mechanisms identified in the model are capital flow surges, in other words, increases in foreign capital inflows, and through GDP growth. The model provides a framework for comparing the probability of a credit boom and credit bust. To do that, based on the advantage of the models, the exchange rate is the only tool that can be used to decrease the probability of a credit boom. Increases in the long-term interest rate and capital flight amplify the credit cycle. Moreover, the fact that surges and flights were relatively correlated implies that there's some underlying feedback loop between two offsetting one another. For instance, capital surges could lead to an appreciating exchange rate, and this in turn leads to capital flight. Other findings include synchronization of the domestic business cycle and the domestic credit cycle. So finally, in conclusion, international capital flows integrate economies into the IMFS and the global credit cycle. However, as outlined above, this capital mobility impacts financial stability. The findings of this paper therefore contribute in developing and analyzing the framework for macroprudential policy. Ultimately, funding composition matters for credit cycle and subsequent financial crises. So thank you for this opportunity. Are there any questions?
Wonderful, David. They were very, very nice. Thank you very much. Thank you very much. If there is no obvious question now, I'll ask you a question. I'll start myself. One question is about when you introduce the macroprudential policy instrument in your regression, you have a significant change also of the probability of boom and busts, isn't it? There is a change in the coefficient in your surge and stop as well. How do I interpret this change in coefficient when you introduce the prudential index? One. The second one, and then I can answer both. The second one is when you talk about heterogeneity effect. Are you talking about heterogeneity effect, or are you talking about heterogeneity of dimension of the credit cycle when it's boom and when it's bust? Cioè, that the two episodes, credit boom and credit bust, credit inflow, credit outflow in your capital flows, a very different speed of, for credit flows that will be long and accumulating in time, while credit bust will tend to come sharp. Therefore, are you talking about this heterogeneity or an heterogeneity in response? So the two have a different effect. You know,
okay, thanks, Professor. When I spoke about the heterogeneity, I meant the heterogeneity of the capital flows. So now we've just aggregated the capital inflows and outflows, right? So we're distinguishing between say a surge and a retrenchment, because a lot of previous papers would lump those two together. So that's what I meant by capital flow heterogeneity, and not heterogeneity of in the credit cycle. On the first question, okay, I've not included the baseline results on once I've included the prudential index, because the coefficients will be marginally different from when we because the sample changes, right? So what's the surges? The surges so 0.190, and then it goes down to okay, I didn't include it here now on the slide. Let's go to 0.567 and then minus 0.60. So yeah, so the magnitude obviously it has changed here, but we're not really available apples to apples at the moment, because the sample is different here, and this is a regression excluding the control variables now. So I think we'd expect the coefficient change. I'll have to share the full paper with you to better compare. I don't have the table like on me right now, but I think we will see that there's more consistency when we have full set of results to look at.
Okay, Gideon, go ahead.
Thank you, David. This is an excellent presentation and really interesting one so far. If you can go back to your slide 10.
Yeah.
The one thing that's unique about South Africa, you can literally see from this picture. After 2008, after the crisis, our banks started behaving very differently and our credit cycle changed. So
yeah, it's
I think,
really flat.
Yeah, so I think one should either think about a time varying type approach here or a structural break type approach here. And perhaps for the PhD sellability, comparing with other countries where this didn't happen, because I think this is a very unique thing to our South African situation. So comparing two countries where this happened in one and not the other might be very interesting, where the capital control situations are more or less comparable. So this is my main concern about what your results mean before and after this break. But beyond that, a really nice analysis.
Thank you. Thank you, Dr.
One more comment that you can highlight maybe later in your results. The effect of the VIX is particularly distinct. In your booms, it's, I hope I get the order right now, and then revealing my badness at calculus now, is it's concave in booms and convex in busts, which is sort of exactly what we'd expect, but not something I've seen in another paper. So that might be interesting to explore. So, so the VIX there. So the fact that the linear term is positive and negative, the quadratic term is negative in the one and they reverse signs in the other, is a sort of interesting thing that I've not seen anyone talk about.
I did notice that. I just assumed that they were just like offsetting each other in slightly different ways.
Yeah, but the asymmetry between them, so the degree of concavity and the degree of convexity here might actually be very interesting and have interesting economic meaning, because far more risk-averse behavior in a bust rather than far more risk-loving behavior in a boom is an interesting economic result, if I interpret it correctly. Anyway, but thank you.
So
yes, I think you did.
So
you did
using
your
exactly the same
derivative
set of
correct. Go ahead, David. Sorry.
Yeah, we're essentially using exactly the same set of independent variables of both equations. We're just changing the dependent variable, and that's why I chose to use the Probit in both regressions so that we could better compare them. Because the busts aren't very symmetrically distributed, so it would actually be more appropriate to use like maybe like a complementary log framework. But then I felt that you would lose that comparability between the two models. That's why I chose to use the Probit, even though maybe it wasn't the best specification to use.
I think you're misinterpreting. I thought this is a positive thing that you can sell. So
yeah.
Cool.
Great, thank you, David.